Thank you for joining me on the first two lessons of this module. Now we are going to look at the crux of the matter. The actual power flow is what we discuss in this lesson, and it's the last lesson for this module. So it also includes some examples. Make sure you have a pen and paper ready so that you don't just look at the examples, but you become actively participating in them. So our power transfer really looks at your power flow that you have in your system. And this power flow would flow from one point to the other. The one point flows from is A going towards B. And you would find that between these 2 points, you would have a potential difference. Although we try to limit the extent of that potential difference by what we discussed in lesson 2 on how to boost those voltages. This potential difference causes then your active and your reactive power to flow between these 2 points. And how they flow between the 2 points is not the same. So your active power will flow from A point to B point, whereas your reactive power will flow from B point to A point. So how we say them, we say that your P, which is your active power, is transferred from A, while your Q, which is your reactive power, is transferred to A because it goes from B to A. And the potential difference between these 2 points can be as a result of either a magnitude or it can be a phase shift. We usually prefer it to be a phase shift than to be a magnitude. So here now, what I've just popped up in front of you is basically showing that voltage between those 2 points A and B, we would call it VAB. And that's the magnitude of the 2 voltages combined together. And you can see them written below that first line as VB and VA. Then if you look at the triangle next to that, you can see that there is a phase difference between the 2 voltages that you had. Whereas in the incoming, they were just a straight line, but now as they are outgoing, you can see that there is a phase shift between the A and the B. And that angle, which we call the advance angle, will flow from your leading to your lagging voltage. Okay, so your leading being the one that would be in front and your lagging obviously at the back due to degrees. Now at the bottom of this, you can see that I've got the circuit, and in my circuit I've got my A point and I've got my B point that are both generating or power sources. And you can see going towards this impedance, which would be an impedance on my interconnector in reality, Z, we have got that IAB and that IBA. So that Z or impedance can be my synchronous impedance of your machines, or it can be my line impedance of an actual transmission line that I have. In both cases, those would be seen as my interconnector between my supply point A and my supply point B. Then at the bottom, with what has just popped up on your screen now, you can see that I've put in 2 triangles there, where the first one is familiar because you've already seen it on the right hand side on top, where I've got my EA, EB, and VAB. Before I had them named as VA, VB, and VAB, so it's the same thing. And using Kirchhoff's law of voltage, you can obviously see that my VAB would be equal to my EA minus my EB. Then looking at the triangle that is on the right hand side in the same pop-up that I've just done now, I've now replaced my EA and my EB and my VAB with the VI and my VJ as well as my VIJ. So my VI, which where I have an I in there, I say that represent my leading voltage. And then where I have a J, I say that represent my lagging voltage, which I usually say I reference that one to be sitting at 0. Using the same Kirchhoff's law, I can utilize exactly what I had on the left-hand side and say that my Vij will simply be equal to Vi minus Vj. I want you to note that although we had said your voltages are always given as a line to line voltage. So here you need to make sure for your calculations that you transform that voltage from a line to line into a phase voltage. So that's why I've put in brackets the phase, so that you do not forget you must utilize your phase voltages when we go into all of these power transfer calculations. So then my Vij, I can simply replace the Vi and the Vj and say it becomes my Ij multiplied by my Z. All right, so that will be my current between my point I and my point J times by the impedance that I am going across. And so therefore I can clearly be able to put my I or current as a subject of the formula and say it will be the same as my Vi subtract my Vj divided by my impedance of that system. So in this slide is where I want you to either have your pen and paper ready or to take out your notes that you have on module 3 so that you can look at the two at the same time. The first picture that I show in front of you now is you've got two generating substations, A and B, and you can see that at A, I've got the voltage EI at that displacement that I've put in there. And then you can see that at EJ, I've got my angle to be sitting at 0, and EJ is at B power station. So it means that my A is my leading voltage and my B would be where my lagging voltage at EJ is going to be at. Then I'm going to introduce you a new angle which is called my beta, and this angle really is going to be my load angle, and that angle will be your angle that you get between your Vi over Z and your Vj over Z. So we say that they will lag Vj and Vi by an angle that you call beta. Also, what I want you to note is that you have got your complex power SA, which is star. Because it's complex, it also utilizes your angles, remember? Unlike when you just have the power that you do not utilize those as apparent power. So you've got a PA plus or minus JQA at your substation A. And then at your B, you've got your SB is equal to your PB plus or minus JQB. And what you have now at the bottom, there is a bus bar there because you can see that there's thin lines, both coming from your A and your B way at the end of that arrow. I'm sorry that I can't point, but this thing is not allowing me to be able to point to you. So that's why I'm trying to be as descriptive as I can be. So then at the bottom, you can see that you have got a load coming out from A and you have a load coming out from the bus bar that is sitting at B. So that load at A would be my SA load, which is equal to my PA load plus JQA load. And the one at B would be my SB load is equal to PB load plus JQB. And what you want to be generating for, you're wanting to generate at either A or B such that they can be able to feed their load, number one, but they must also be able to supply that interconnector, which is your line going from A to B, and the load at the other side, for just in case you had to lose one of these power stations in your network. So now I go and I introduce to you my third angle. And this third angle, which I call my phi angle, is really the angle that I will have between VI as well as my current. So therefore, my IIJ consists of two components. It was my IIVI over Z and my IJVJ over Z. And so therefore, I apologize for that distraction. So therefore, my IIJ would then consist of these two components, your II and your IJ, where your II is multiplied by your VI over Z and the other one is VJ over Z. So it becomes the subtraction between the two. So therefore, my PI would then be equal to my VI, and I multiply that by my IIJ, and I say times my cos phi, which is the angle between my VI and my IIJ. And this can be rewritten as per the bottom where I want you to see the bolded, where it just goes that it's your VI into VI over Z cos beta minus Vj over Z cos beta plus that displacement angle that I had. So because I've said here that my magnitude is usually the same, you will see as we go along, and I've written on the side as well in pen, that then my PI is VI squared over Z because my VJ and my VI are same in magnitude. And then in brackets, I only have the cos beta minus the cos beta plus my displacement angle. Then I go to the QI formula as well. This one will be VI times my VIJ sine phi. And that I can transform at the end to QI is equal to VI squared into sine beta minus sine beta plus my displacement angle. I then now look at my J point so that I can be able to give you the formulas for PJ as well as QJ, which will be the ones at your B power stations. And you can see from the derivation that this will equal to my VJ IIJ, cause that same angle, and therefore it can be seen as VJ squared into cos beta minus my delta minus my cos beta. So let's call delta the angle of my displacement. Then for my QJ, I can have my V squared, VJ squared over Z into sine beta minus my delta minus my sine beta. And in the figure, it can then be seen that my SA star will be equal to my SA load plus my SI. Okay, SI is simply going to be my PI plus JQI. Then my SB is going to be my SB load plus my SJ, which is coming from this PJ and QJ. So now that we have finished giving you a bit of the theory, this now comes and I'm doing for you the actual exercises that are at the back so that you can be able to familiarize yourself on how these concepts are actually being applied. So for 4.1, which is the first question in there, we are asked to work out what my SI and my SJ are going to be. And by doing that, state what is being transferred and received. So I do my IIJ, which is going to be my VI minus my VJ over my Z. I must remember that my 88 is going to be my line-to-line voltage that you've been given. don't forget to divide by the square root of 3. I then get an answer for my current as per what you see here. Once I get my current, I can be able to calculate what my SI is going to be. And I can then say simply becoming that square root of 3 VI and my IIJ. Now remember, if I star the current, it means I want the conjugate of the current. It means it's the negative of that current that you had worked out. I then am able to get this, and that gives me what my angle is as well between my 2 points. So it then goes to say, if I transfer that SI that I've just received into P and Q, I can say 171.335 megawatts is being transferred from A, and I can say that we are receiving 25.1547 MVAR from B. Then I go to my SJ. I do exactly the same maths on it, and I can deduce that from this amount that I am getting. It simply means that my B receives 165 megawatts from A, and it transfers 53.106 towards my A substation. Then if I go on onto this one, I will then be able to work out what my SA total is, which is going to be really my SA load plus my SI that I just worked out. So my SA load, they gave it to me, and then I've just calculated the SI on the previous slide. I can get the total for SA, and I can always put that into PA and QA. Then I do the same for my SB, where it now becomes my SB load minus SJ. Okay, please note it subtracts your SJ. So I then can say that is my 480, and I minus what I got previously, and I can work out what my PB and my QB are at. Then from that, I can be able to work out what is my lagging angle and what my lagging angle also at B is going to be by taking the degrees that I have received previously. Remember what phi was as a degree? It was the combination of beta plus that displacement angle, which I said let's call delta. So these are the two answers that I get. Please go back and look at one carefully and try to do it to see if you get the same answers. Then I have got my second question. So in my second question, you can see there is the network given to me, but you can see that I am not given the angle at B substation. And what have they done else that is going to be confusing a little bit is that we have now put B as our leading substation, and A is now the one that is lagging because it's the one sitting at 0 degrees in voltage. So please take note of that. So I go and I work out what my delta angle by putting in that formula for my PJ. Once I have that, I can be able to work out what my IIJ is by simply saying my VI minus my VJ over Z. Don't forget the square root of 3. That takes it from line to line into a phase voltage. I can then from there get my SI, and I can get what my SJ is. I then go and say my SA is going to be SA load minus AJ. Why is SA now minus AJ? Because remember, they've changed the norm by making B my leading and A my lagging. So you just make sure your formulas, you go and change according to where the stations are at. And my SB will be my SB star load plus my SI. Or you could have done this the other formula. That's why I wanted to put it in here so that you know even if you did it this way or the other way, you would end up getting exactly the same answer where you work out your QI and you work out what your PI is using the formulas. You get your answers and those will lead you to what SI is, and you can do the same for your QJ, PJ, and then you can be able to work out what that SJ is exactly from those two as well. So it's irregardless of how you do the calculation, at the end of the day, you are still going to come up to the same answers for your SA total as well as your SB total. So the last part of this question then asks for your power loss that you have in your system, and that can really be seen as your PIJ, which, if you remember, your formula for your three-phase could be simply the 3 times your I squared of ij multiplied by r, not z guys, but r. So that would be 3 multiplied by your current multiplied by the 1.45, and you would get 5.15 megawatts. Or you can do it in the manner where you can say your Pij is simply your Pi subtract your Pj, and it would give you exactly the same answer. So it's up to you really which method you utilize. It gets to you to be the same answer. We now move from that point to these last two questions that are asked us to do. So for my 4.3 then, I have my system. In my system, they can show now that I've got my VI and it's leading and it's back to being substation A, which is our norm, and B being my lagging at substation B with a VJ. So therefore, I can work out what my IIJ is, and then I can work out what my SI is, and I work out what my SJ is. And remember, with SI, I know what being transferred is my P, and received is going to be my Q. And with my SJ, my received is my P because it gets received at B side, and my transferred being my Q point. Then I can work out what my SA total is. I call it total, although it's just written as SA so that we understand holistically, which is my SA load plus my SI. And I do the addition, then my SB becomes my SB load minus my SJ. And then I'm able to calculate what that one is as well. So this time around, where before they asked us the power loss, they're now asking us our Sij. So it simply becomes Si minus Sj, and I can be able to get what that is going to be. And the angle there is going to be the 78.3. So I've got a power factor of 0.202. Then with my Pij, I can utilize any of those two formulas of the 3 times I squared r, or I can say it's my Pi minus my Pj, and I will be able to get my 3.07 megawatts. In fact, here they made it very simple and said it's my Pij, which can be equal to my Sij cos my angle that I just got from 4.3.3. Okay. So this one is now the last one of the exercises that I show, and you are asked here to calculate what your advancement angle is because you can see there that it's sitting as unknown. What you would then do is you would first go and find what my PI is because you've been given PA and you know what PA load is going to be based on your SA load that you have. You are then able to get your PI and then you can substitute it into that formula that says PI is equal to VI squared over Z into cos beta minus cos beta plus my advancement angle. I then go and I'm able to calculate what my advancement angle is going to be. Please do the same thing. Try and calculate the PI as well as your advancement angle to see that you're getting exactly the same things. Once I have this now, the last part was for me to calculate what my power loss in the system is on my interconnector. So therefore, I can find what my IIJ is, knowing that is VI minus VJ over Z. And once I have that current, I can then go and put it into the formula that says 3 times my I squared R, and I can get my 14.2 megawatts. Thank you for your participation in this module. Please go and do your tutorial 3. First, go and practice all of these exercises from the 1 up until 4. If you require more to practice on, you can contact me so I can send you the rest of the exercises in the textbook, should you not have a textbook. I ask you as a student again also to go into the textbooks and do all the other examples that are in the textbook, because you can see I went straight to the exercises. So to allow yourself for more practice, don't only do the exercises I did with you now, but go into the textbook and do the examples. If you don't have access to the textbook, let me know onto the group WhatsApp so that I can actually just try and scan them all in and send them to you guys in the WhatsApp group. All right. Then the day after you have done all these exercises and examples, you need to go and do your tutorial 3. Then only can you move off to start on your module 4. Thank you very much for your participation into Module 3, Power Transfer.